Hi everyone, Mrs. Below here. In this video, I'm going to go over how to complete the Gay-Lussac's Law Lab. So the first thing is make sure that you have your data completed. This is just an example of what your data may or may not look like. Next, you have to make sure that you have a proper title for Data Table A. So when you read the title of a table, it should tell you exactly what the data on the table represents. So in this case, we had on this table the pressure and temperature of, now if we think back to the experiment, we had this flask which contained air, and we put that flask in, we had 4 different situations. This situation here that you started with, the flask in the ambient air, so the air surrounding it. You put the flask into a cold water bath, a room temperature water bath, and a hot water bath, and then recorded the corresponding pressure using veneer equipment. That's the name of the equipment. So if I wanted a descriptive title, I would add something, so you can phrase this however you want, about the fact that the pressure and temperature was of the air that was inside of the flask, and it was measured using veneer equipment. So however you want to phrase that, make sure you include those other 3 things besides this in your title. So the fact that the air was in the flask, and then that the equipment we used to measure that was called veneer equipment. So again, the flask, this stayed the same throughout the whole experiment. So that will help you answer this question, number 1. What variable, if we're talking about gases here, was kept constant or the same? And then based on your data, what type of relationship is there between pressure and temperature? Is it direct or inverse? You just have to write one of those 2 words for your answer. And then for question number 3, you're going to draw a picture and provide a little description. So your picture could be the flask. Okay. And then inside of that, you can do the 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could draw the flask. So first, I want to make sure that I have the same amount of molecules in each. And then you need to indicate a couple things in your description and in your picture. So in your picture, you're going to use a short arrow to represent that the molecules are moving slow. And if you want, you can make them different colors too. And then a longer arrow to represent that the molecules are moving fast, based on the 2 different conditions that you had. And then have a little description for each one to describe what's happening in terms of the temperature, the speed of the molecules, and therefore how is that affecting the pressure for the flask in the cold water and the flask in the hot water. Next, you have this question here. Absolute 0 is 0 Kelvin, which is the coldest possible temperature. What would 0 Kelvin be in degrees Celsius? Show your work. So you want to use this equation to help you answer that question. If you have 0 Kelvin, what would that be in degrees Celsius? And make sure you show your work for that. And then what would the pressure be in ATM at absolute 0? If you don't know, go back to the FET and put the temperature at absolute 0. So you can go back to the FET, the Intro to Gases FET, and you can just click on the link right here in your Intro to Gases FET. Pull that up, hit the play button. Ideal. add the gas molecules in. I'm going to make the volume, hold that the same, and then make this go to absolute zero. The temperature is up here, and then tell me what the pressure of that would be. You don't have to show work for that. When you also have to create your graph using this data here. And to do that, you're going to watch this video. And this one you only need if your graph looks a little wonky. You most likely don't have to watch the second one, but if your graph still looks weird, you could watch that video. And then you're going to paste the graph into this space here. You can snip it using the snipping tool, or you can actually click on the graph and copy and paste it and put it right here in your OneNote. Then on your graph, you're going to have an equation, y equals mx plus b. Obviously, this, and this, I'm sorry, m and b will be actual numbers that come from your graph. And make sure on your graph you note what each axis was. So what was the, so if we're talking about a graph real quick, this is the x-axis, this is the y-axis. Based on your data, which thing did you have on each? Was pressure or temperature graphed on the x-axis? Was pressure or temperature graphed on the y-axis? And then what you can do is, based on that, you can plug in those values for x or y. So if the, what would the temperature be? So you're solving for temperature, so you have to figure out if that's x or y you're solving for. What would the temperature be in degrees Celsius? If the pressure, so you want to plug in 0 atm for the pressure into your equation here. Again, you got to figure out if you're plugging that in for y or x. And then solve for the temperature. And then that will tell you what the temperature would be in degrees Celsius if you were at absolute zero. And then that value is what you're going to compare to the accepted value. And you're going to see how close were you to figuring that out. Again, in the lab setting, we cannot go all the way to absolute zero. That hasn't been done. That's impossible to do. However, we can collect data and we can create a graph with that data and use that graph to make a prediction. Well, what if we were at absolute zero? What would the pressure be? What would the temperature be in degrees Celsius? So for the last question, question 7, now you will figure out how close you were to predicting the value of absolute zero using your data that you extrapolated. So basically using your data to make a prediction. For the accepted value, you will use the value of absolute zero, Kelvin, but in degrees Celsius. So for the accepted value, you're going to use the value of absolute zero, 0 Kelvin, but whatever that is in degrees Celsius, refer back to your answer to question 4. That's what's going to go here. And then the calculated value is what you got using the data from your graph to predict the temperature of absolute zero, but in degrees Celsius. So the two things you're plugging in here are going to be in degrees Celsius because that's what we use to measure temperature in the lab setting. And then you are going to figure out what your percent error was, which hopefully will be pretty low. So make sure that you answer all of the questions completely and you have your graph copied and pasted here into your OneNote. And don't forget then to turn this into Teams when you're done.